So last session we were discussing one transistor DRAM. We continue that discussion. So we have seen an expression for this leakage current when VGS is, you have disabled this word line is 0, so transistor is off. So even then there will be leakage current through the transistor. That leakage current is written something like this, minus Cs dVs by dt. So let us define the whole time from this. So this is the circuit. This is the circuit, and due to the leakage current there will be the charge leakage. So this charge leakage is expressed by this. So this is over the time t. So from the maximum value VDD minus VTN, it deteriorates. So it reaches a value. This V1 is the minimum value which can be considered as a logic one. So the time elapsed between these two, from maximum to this V1, this time is called the hold time. So this is called the hold time or refresh time or retention time. TH is the hold time or retention time. Hold time or retention time. Okay, and how to define this? So it is the longest period of time that the cell can maintain a voltage large enough to be interpreted as a logic one. So this is the time, the largest time the cell can maintain a voltage which is large enough to be interpreted as a logic one. So this is the hold time. So this is the time that the cell can maintain a voltage, large enough to be interpreted as one. So let us see this. We have seen the expression IL equals minus Cs delta Vs by delta T. So this whole time TH, let it be mod delta T, that is equal to minus Cs by IL delta Vs. So it is very clear. So this is the expression for this. This is the expression minus Cs by IL delta Vs. So it is if IL equals 1 nanoampere. Suppose if IL equals 1 nanoampere, Cs equals 50 femtofarad, delta Vs, let it be 1 volt, then TH equals 0.5 microseconds. So if this capacitance value I am assuming as 50 femtofarad and this delta Vs I am assuming as 1 volt, if my leakage current is 1 nanoampere, I must refresh the cell in every 0.5 microseconds. So this is the concept of refresh operation. That is why it is dynamic. That is why this is called the dynamics. So this is about the dynamic refresh operation of this. Then let us see DRAM read. DRAM read. So this is my DRAM. So this is word line and this is my bit line. So this capacitance associated with the bit line is shown as C bit. This is Cs. So during read, so DRAM read, that is important. DRAM read. So Vs on read, it moves charge from the Cs to the C bit. There will be a charge transport from Cs to C bit. So from the maximum value, Vmax, from Vmax, there will be a charge transport. During read operation, from Vmax, charge will be transport. Charge will be shared. Charge will be shared from Cs to C bit. So the voltage Vs falls. So this voltage Vs falls to such a level that this Vs reaches a point Vs equals Vf equals V bit. So this charge redistribution will be ceased when this voltage is attained. So charge redistribution ceases at this point. CSS at this point. Charge redistribution CSS at this point. So this we can write QS equals conservation of charge. QS equals CSVF plus C bit VF. That is VF multiplied by CS plus C bit. This is equal to what? This is equal to CS into VS. So we can write this final voltage VF equals CS by CS plus C bit multiplied by VF. So this is important. This is very, very important. So this is the dynamic RAM read operation. So when a 1 is stored, maximum value is VDD minus VTN. So that is the VS. So there will be leakage and charge redistribution is there. So during read operation there is a charge redistribution between these two capacitors. So this charge redistribution ceases at the point when QS equals CSVF, when VS equals VF equals VB. At this point we will be able to write an expression something like this. So you get the value of the final voltage at this point. So we stop here for 1TDRAM. And one more point I must point out, the maximum, the operation to overcome the charge leakage, there must be a minimum refresh frequency. Minimum refresh frequency is minimum refresh frequency equals 1 by 2 TH. We have seen what is TH, that is the whole time. So 1 by 2 TH is the minimum refresh frequency. So that is on dynamic RAM. We continue this in next session. Thank you.